I'm Rachel White, and I have been working on the development of an anomaly reporting framework in partnership with and under the supervision of Kath Lee, as well as Erin Peterson and Kerry Mengerson. This part of the project follows on from the anomaly detection work Kath has just presented. So we propose an anomaly reporting framework for high-frequency water quality data informed by the experience of responsible agencies around the world. The aim of an anomaly reporting framework is to provide a standardised system for labelling and reporting anomalies that can be adapted to meet the needs of individual agencies. Establish a common language among water quality data managers and data users to improve interoperability of data, and ensure the data reported meet the needs of all end users, such as researchers, data managers, general public, policymakers, traditional owners, sensor technicians and others. Based on the research we have conducted to date, we have found that water quality data have unique challenges that can't be met by anomaly detection and reporting conventions developed for other disciplines. Challenges include seasonality, multivariate dynamics, spatial heterogeneity, and sensor failure. Our research findings suggest there is currently no conformity on how anomalies are labelled and reported. And not only that, but even the interpretation of commonly used terminology varies. Instead, in the absence of an existing framework, anomaly labelling practices have developed in isolation for specific purposes and the individual needs of each organisation. Based on these findings, we believe that a nuanced anomaly reporting framework would be a beneficial tool for water quality data management, just as other projects aim to harmonise and standardise approaches to data sharing and reporting, such as the collaborative Human Variome Project, a global effort to collaboratively develop technical standards and common approaches to reporting information on genetic variation so that data from different sources can be easily shared in an interoperable way. We began this work in April this year, and since then have surveyed water management agencies across the world on their anomaly reporting practices, reviewed a number of data portals and looked at relevant literature, and we are now in the process of drafting a set of proposed guiding principles that should underpin the development of an anomaly reporting framework that we would like to collaborate on with industry. In order to develop a relevant and practical framework, the experiences of those at the forefront of publishing time series water quality data are vital, so that learnings can be combined and built on, rather than reinventing the wheel. Such a framework will be an especially important and useful resource moving forward and for agencies new to big data anomaly reporting. So the survey we conducted aimed to collate and analyse the quality assurance, quality control practices of organisations that monitor fresh waters. Specifically, we asked organisations to detail their current quality assurance and quality control practices, what issues they were looking for, what was working well and what wasn't, and for any documents they had that outlined their processes. I won't go into too much detail here. So in short, we were really looking for practices relating to the management of water quality or quantity time series data collected using in-situ sensors from surface freshwater sources. I believe some of the agencies we surveyed may actually be attending today, so we would like to take this opportunity to again extend our thanks to those agencies for taking the time and effort to contribute to this work. We used a snowball sampling approach to identify and contact water management agencies spanning research organisations, regulatory agencies, non-government organisations and government organisations. Overall, we contacted 42 agencies across the world, including from Oceania, North America and Europe, and had a response rate of 74%. This clearly demonstrates there's an interest and a need across a diverse array of organisations for some form of a system or framework that will bring greater coherence in the way data anomalies are reported. Here we've listed some of the common responses we received. Quality control processes are often undertaken manually, which is labour intensive. The processes are mainly aimed at identifying sensor drift, episodic events that damage sensors, missing data, spikes and sensor failure. Sensor maintenance is a key component of quality assurance processes. Environmental extremes are common causes of sensor failure. Some of those reported include turbidity, sedimentation, and frozen water. Resourcing was the most common issue raised. Budgetary constraints, finding people with the right skills, and managing the vast volume of data collected, both in terms of storing it and processing it. Many agencies don't actually have formally documented quality assurance processes, and currently available sensors and software have limitations. A review of the 37 quality assurance documents we received found that quality assurance processes covered a range of activities, but tended to focus more strongly on field procedures and calibration, and less so on data management. Where data management procedures were included, they focused on corrective actions for data errors, calculating a quality confidence flag, and how to report corrected data, such as including site information, the type of error, surrogates used to calculate a corrected value, and comments. Overall, we found that the majority of quality assurance documents did not prescribe labels for the types of anomalies reported. Having found the documentation that we received in response to the survey was more focused on calibration and validation procedures, we changed tack and reviewed 14 publicly available data portals, looking at both example datasets and accompanying explanatory notes that outlined quality codes for data errors. We also corresponded directly with a subset of organisations we had identified as publishing real-time data to ask more specifically about their data management practices. From that review, we found that data management processes vary among organisations, such as some using manual processes versus automated programs to review and validate data. We also found there were some consistent practices employed, such as placing emphasis on labelling anomalies with data confidence flags over other annotation descriptions, and the common practice of ranking codes in order of data confidence, so a lower number generally indicates a better quality of observation. Most real-time data are published as raw data that have not undergone any automated processes for identifying and labelling anomalies. Instead, data are accompanied by a stipulation that all data are provisional. Most agencies publishing real-time data are using off-the-shelf software packages such as Aquarius and Hydrus 3 that are specifically designed to store, process and publish water quality data. Many organisations are developing real-time data processes in isolation. And finally, the results demonstrate just the scale of resources required to collect, quality assure and process big data. Based on the information collated to date, we have come up with 4 recommendations to help support the development of an anomaly reporting framework. These are facilitate collaboration opportunities, add more labels to anomalies to provide more transparency and context, review existing water quality data management software packages, and acknowledge the resource intensity of managing the volume of high-frequency water quality data and developing solutions to maximise the value of big data. Regarding the first recommendation, as I mentioned earlier, we are currently in the process of designing a virtual workshop for relevant agencies to consider the guiding principles that should underpin an ARF. We'll present this workshop with a proposed set of principles to facilitate a discussion. This is currently in development, and next I'll give a very brief overview of where we are to date. In practice, what we hope to achieve through this project is consensus on a minimum set of guidelines for reporting anomalous observations, including annotations, labels and definitions that would improve the consistency and interoperability of water quality data. To elaborate, annotations are the types of information that should be reported with an anomalous observation to provide further context to the data user. An anomaly label is the nomenclature used to label data in a way that describe an anomaly's characteristics, such as its graphical features, possible causes, or likelihood. And finally, the definitions of those labels. This may be in the form of a data dictionary or explanatory note that provides meaningful and explanatory textual descriptions. These principles are in no way finalised, but they represent our early thinking on what we plan to propose. So first one, transparency. This is about providing detailed information on all useful parameters related to anomalous observations in order to achieve maximum transparency of the data. More specifically, annotations and labels should be used as tools to support users understand the full context of anomalous observations. Traceability. This is about providing sufficient information to enable replication of anomalous results identified in the dataset and any corrections that have been applied. Anomaly detection methods can be opaque, therefore providing supporting information such as the algorithms used to identify and automate corrections can increase trust in both the data analysis and the results. Consistency. As much as possible, we'd like to see the consistent application of annotations and labels across the water quality data management community to support common interpretation of anomalous results. This applies to both the nomenclature used and definitions to inhibit the same term being used for multiple anomaly types and equally different terms being used for the same anomaly type. And finally, usability. This is about accounting for the different needs of all end users, including both technical and lay data users. Annotations, labels, and definitions should aim to be self-explanatory, accessible, and meaningful. And to finish up, our next steps are to finalise the draft guiding principles I just spoke of, and to plan a number of workshops to accommodate organisations across different time zones. As mentioned, we intend that the anomaly reporting framework is informed by industry to ensure it meets the needs of industry. We hope to send out more information on this in the new year. Thank you.